Hi, in this video I will show you the modular snap system runtime plugin VR example. So there's a level when you start. It's basically I started with the default VR template of Unreal Engine and modified it. Here you can teleport yourself if you press the button on the motion controller or the stick on the motion controller. So let's go here. Like in the example of the VR of the Unreal Engine, there are some cubes. I made them smaller because well, the default cubes were too big. And you can take them if you use grip button. So I'll take a cube. There, if you can see on the hand, there's a little sphere I left. It indicates where it will collide, detect the thing you take. So if you approach the hand, you see it changed its the position of the fingers. So it shows you that you can take something. And it's more or less like in the default example. Now the new thing is that you can snap those cubes. So you can approach one cube to another, and now you can snap it. So you have one object composed of two cubes. Now what you can do? So to take, you use grip. To release, you release the grip button, and if you take with one hand and you grip with another, it will just still like that. And now if you want to split those two cubes in this object in two cubes back, you can press the trigger button and hold it, and then press the grip. So you see it's detached. And another thing is that we have here two hands. So with modular snap system runtime plugin, you have this green preview that appears when you want to snap the thing. And the problem with two hands is that each hand have a preview. You see, there's two of them now. So what I did, at first I used a modifier key like trigger, like in the normal example. I use control click for indicate that I want to attach the thing, but it was a little bit complicated. So now the system is different. It will just detect which hand moves. So you see the right hand moves. Here both hands moves. The right hand moves, and there is a preview only for the right hand. And if it stays still for 1.5 seconds, the preview disappears. And when there is no preview, it will just fall down. So that's the approach. And you can change the sensitivity of those of this motion detection by changing the minimum speed and minimum angular speed of the hand. So that's how it works. And here we can build some stuff like that, and we can remove stuff. And there are some cubes like so, gray cubes that are also snappable too, but they are static objects. So you cannot take them, but you can attach to them like so, and you can use both of your hands. And yeah, basically that's it. for this example, and now I will show you how it's implemented in blueprints. Now let's take a look how it's made. So basically I took the default Unreal Engine VR template and modified it a little bit. So the things like teleportation, for example, it's exactly the same as in the template, and this level more or less the same, the cubes. Let's look what is specific to this example. So we have this pawn, which is motion control and pawn detach, and here there is not much difference, except that it uses BP motion control detach for the hands instead of the default BP motion controller. So the most of the code is in those hands. Let's take a look. So the hand itself made like this. It's basically the same as in the template. You have the hand, the mesh, attach it to the motion controller component, which will move the hand in your level. And you have this little sphere, grab sphere, which detects if there is something under the hand, so we can grab or not. So I made it much smaller than the default sphere. Now, concerning the code, most of the code is located here in the grabbing event graph, and it's like similar to other MSSR example. So in the this event init preview, which is called in init in begin play, we create the preview actor with our settings and store in the variable preview, and we use async mode, so it will perform on a separate thread, and it's more performant, which is, I think, important for VR. And then we have grabbing and releasing stuff made in those two events, grab and release, which are hooked to the grip button, press and release. Let's take a look how it's done. When I push the grip button, I will first check if I'm not holding already something. Attached actor variable is the variable that holds something we are holding now. And if I'm not holding anything, I will look what can I hold. I will call this method get actor near hand, which is basically will run a overlap query and look if there is something in this little sphere here in the middle, and I lost it. And if there is something, well, it will check if there is a tag pickup and then return it. So all those cubes you can pick in the level, they have a actor tag pickup. So we know that we can pick it. For example, those don't have. And then if we found something, if this thing returned here is valid, then we will grab it. So here there is a if is forced. Is forced is basically if you push the trigger, this variable is set to true, and it means that you want to detach the cube the particular cube you have under the hand from the other cubes to which is probably is attached. And if this trigger is not pressed, it will not detach the cube, but pick the whole the cube itself and the other cubes attached to it, the whole structure. And then it will make the cube we pick it up, detach it or not, as the root of the attachment tree. And that's kind of important for the organizing things. And then disable physics and then attach it to the hand. It will attach it to this attached actor place send component. So this component shows us where relatively to the hand the cube will go. And then it will rumble the controller. Disable this because it made some strange effect, but you can go there and re-enable it. And then it will finally show the preview of the attached actor. And for the release, it will first check if we have something in the hand. We'll detach it, first things. Hide the preview. And then we will check this variable want to attach. So this variable will decide if we want to drop just the thing or if we want to snap it to something. If we want to drop, we will just put back the physics simulation on the cube and forget, so it will just fall down. And if we want to attach, we will snap it. Before I talk about snapping, this variable is set by the detect move function. Detect move function basically will check the velocity of the hand and the angular velocity and compare them to some minimal values that you can set up. And if the hand moves faster than that, then it will tell that it wants to attach. And also if the hand is moving slower than that, but a few time ago it moved fast, and this time is less than last move time. I'm sorry, less than move delay. Here 2 seconds. So if we move it fast 2 seconds ago, we will still return true here. If we stay still for 2 seconds, we will return false, and we will not more wanting to attach. So this variable is set in the tick method. And so if we want to attach to snap, then we will execute the snap actor method, searching for possible snapping location. And if we found something, we will snap the cube. So we will execute the snap actor function, and we will search for the possible snap points around the cube we are releasing now. And if we found something, we will initiate this snapping procedure. So first we will play the animation, smooth move, of the cube moving from the hand to its location where it should go. And then we will simulate physics or not according to which other actor we are attached. So if we snap to another cube that is simulating physics, that it's on the table, for example, then we will put simulate physics to true. Or if we snap on to one of those static cubes, we will put simulate physics to false, so our cube will just be attached statically and not weld, and we will not fall to ground. Then we will transform the cube with snap, so say the source socket of the Ethernet here to a root of the attachment trees. So if there are more than one cube we hold, we will always snap the one who have this matching socket, and for this we will transform it to a root of the tree. And this thing is important because we will then attach it to the actor, to another cube, and if it's a static cube like this one, so there will be no it will be not a physical attachment, but just attach like of static actors. So if you attach the cube, we snap it to it, and this cube itself attach it to some other cube, because this attachment tree is it depends on the order in which you made the things. Then the rest of the tree will just again fall down on the ground. So make that root and then attach it to the cube and then forget it. So let's look at this function MakeRoot. Now before that, let's look at something specific to this example. So you have two hands and you can just steal the structure one hand holds with another hand, or you can take a part of it, like detach a part of the structure. So this is those two events are looking for such stuff. Check object taken is an event that is called on the tick, and it will simply check if we still hold the cube. So it will look if our attached actor has as the attached parent ourselves, and if not, that means someone still took it from us. It will then disable the preview and forget the actor. And this method is called just each frame on tick. And the other method is notify object modified, and that is when we took the part of the structure we hold, like we detached a half of it with another hand, and it will just recalculate the preview. So if we held 3 cubes and we took one, it will update the preview, so the preview also have only 2 cubes. And this method is called in here when we detach stuff in the graph. When we detach stuff, we will check if the structure from which we detach the cube is held by other hand, and if this is the case, after detaching we will call notify object modified on the other hand, so the other hand can update its preview. Now about this MakeRoot, well, it's pretty simple. We give an actor, a component, and we say this component now must be the root of the attachment tree. So for example, if I take this cube, attaches to this one, and then this one attached to this one, the attachment tree will be the root of the tree, this will be the child, and this will be the grandchild. Now when I snap the structure composite of those 3 cubes, let's say this cube snapped to someone, I will simply make this cube the root of this structure. So I will simply detach it from whatever parent it is attached, and I will attach the root to it. So in this case, I will detach it from that's our 3 cubes we hold. So I will detach it from this, and then I will attach the root to it. So now this is the root, this is the child, and this is the grandchild. And that is, as I said, important when we are attaching to static actors, because otherwise, if we just attach this cube, it will just stop simulating physics, and the structure will, the 2 other cubes will just fall on the ground. And now the difficult part of this is this detach. Function, and it's similar to what I explained here. Imagine here we have 3 cubes, for example. This one and this one. And this one, like so. And let's say here in the level I attach them in some order. So let's say I attach this one to this one. You see it here in editor just. And then this one I attach to this one. So we have now the 3. Editor cube 24 is the root, 25 is the child, and 29 and attach it to 25. Now suppose I want to detach one of those cubes from the structure. For example, I want to detach the cube 24. So if I simply, like in the simple example, if I simply call detach from actors, it will do nothing, because this cube is already not attached to anything. It's the root of the. So what this method detach will do, it will basically recalculate the attachment tree, and it will first using MSSR sockets find that those 3 cubes are attached together, and we're starting from this one. So it will find that those 2 cubes are attached to this one and attached together, and it will create a new tree. So in this case it's even simple because they are already together, and it will now, instead of detaching this cube, detach this one and make it so. And for example, if we had another cube, I don't know, here, also part of the same, hierarchy, the operation will again check who is attached to this one. So this one, for example, this one, and then find that it's actually one tree, one graph. So this can be connected to this to this, etc. So it will detach that as a whole. And if, for example, we have another cube here, let's say like so, and those 2 cubes are not attached to those, so the detach method will create 2 attachment trees and break the things down. And that you can also see in the better physics example, or in the physical handle component example. So that's it. Thank you for watching, and if you have any questions, please ask. Bye.